Hi, and welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. For today, we're continuing the Advent of Code challenge, no robotics in this series. Today is day 3, which is called Mull It Over. And essentially the problem today is that we're given a string of characters, and we need to pull out the valid sets of characters. So we can use Mull with round brackets, number, comma, number, round bracket. That's the only valid token in this case. Now, in Advent of Code style, I imagine we'll be expanding on this particular problem setup in future, having only one valid token type. I imagine we'll be seeing others in future, divs, adds, even jumps, and so on. So I want to code this in a way that is expandable for the future. But before digging into the solution for day 3, I wanted to show my extra work on day 2. So on day 2, we had to determine whether a number of reports were safe and count how many safe reports there were. And I got I spent a lot of time trying to solve the problem by using a single pass over the report vector, and then determining if once I wasn't able to get that working, I then tried to figure out the index where the report became unsafe and try removing just that index. And again, struggled to get that working. Now, I believe that one or both of those solutions would have worked if I'd spent enough time handling the corner cases, but there is a slower but much simpler solution, which is to first check if the report is safe already, and second, try removing each element in turn. So only one element at a time. Try removing each element in turn and checking if that makes the report safe. That means that each report, instead of being checked once, could be checked n times, where that's the length of the report, but that's not that difficult to do, and it would break early if it finds the digit that makes the report safe. So this took maybe 5 minutes of coding, having thought about it for a little while. And I can show in 2024, day 2, cargo run, we now get the answer of 658, which is the correct answer. So much, much simpler, much quicker to code, slightly slower in execution, but that really doesn't matter in this case. So that's day 2 complete. So let's start day 3. Going to start again by creating a cargo project. We'll run it to get hello world, and it's extremely quick. And then we'll take our test string. And paste it into the puzzle folder. Same setup as we've been using in the past. Today, I think I'm going to try starting off a little differently. Yesterday, I showed starting to use unit tests to test small parts of the functionality. Today, I'm going to start by doing that. It's a good way of writing your code and checking it works as you go, instead of running it on the whole test input and seeing whether it gives the full answer or not. So I'm going to configure test, mod tests, use superstar, which gives access to everything in the rest of the file outside of the test module. And then I'm going to create a test, and we're going to test valid Mull instruction. And here I'll give it a valid Mull instruction. So let's say let extra equals Mull brackets 5, 4. Then I'm going to do some function call. and then we expect the result to be 20. Now I'm going to start writing the skeleton of what my code will do so that I can change this to-do instruction to the actual function that I want to use. So first let's include the string. So puzzle is include string, same setup as before. Then I will create a structure for this. By doing this, it gives the opportunity to use all the methods on an object type instead of writing free functions. So let's do so this is the toboggan rental computer. So I'm going to call it a toboggan computer. Now within this, I'm going to contain a set of valid instructions. So I haven't yet determined what that would be. Let's call it an instruction for now. And then we'll import from str for toboggan computer. Type error is error. It doesn't really matter unless we do have an error returning from our computer. So we'll see what that we'll see if that happens. And we can do function from str, and there it's auto completing for us. And then we want to return a toboggan computer where the instructions are currently an empty vector, but we will fix that. Okay, now it's struggling because it doesn't know what an instruction is. Let's give it an instruction. I'm going to make it an enum because an instruction will be one of several possibilities. And our first one will be a Mull instruction. Now a Mull will contain an I32 and an I32. This is a Rust enum. Each enum type can wrap some values. In this case, we can multiply two values together. Now this lends itself nicely to a from str for instruction. Actually, that might not be as easy because we want to be able to strip out characters that are invalid due to the problem type. Let's not do that. We'll instead directly construct the instructions as part of from str. Now this should be allowed. And I just needed to save that to be happy. And then the result is expected. So we can give it a sum instead of directly the toboggan computer. Sorry, that's an OK, not a sum. There we go. Now what we can do as well for both of these is use hash derive debug, which allows us to print out the toboggan computer once we've constructed it. There we go. So now we are parsing a toboggan computer from the input puzzle string. And if it fails to parse for whatever reason, then we can give an error message that it was unable to parse the computer instructions. Then we're printing out the computer. The next step is to actually parse out the instructions. I think the actual implementation of the solution depends on just being able to parse the instructions properly. So that's the meat of the puzzle. So I'm actually just going to skip ahead and function execute. This will take a reference to self and it will return an I32. And it's just going to do self.instructions.map iter.map, where an instruction I, we want to match on I, and the reason I'm doing this is because multiple instructions are possible later. Now, this shouldn't be curly, this should be a pipe. Mull xy. X times y. I'm struggling to read this because of all the syntax pop-ups that are coming up. Missing match arm. Struct literals are not allowed here. I think what happens is I need to surround this in curly braces. And then I end the map function there. And it's really struggling. Let's, or rather I'm struggling to get a match statement going. So I'm going to do it outside the map to see what the possibilities are. Okay. Mull xy becomes... that's because I'm using a different switch statement syntax. So that's what it is. I don't want the word case, that's confusing. And I don't want the word default. I should be using an underscore. Although in this case, I don't have any unmatched arms, so I don't need a default. Okay, so this would in fact be an instruction : mull. That's now happy. I can delete this match statement that does nothing. And I'm summing the result of the instructions. Okay, let's create a quick test for this. Function test, computer executes. I'm going to create a computer. I'll create an instructions equals a vec. It's going to create an instruction mull with 3 and 9, and an instruction mull 10 and 2, let's say. So that's 27 plus 20 is 47. So our result will be 47. Let our computer be a toboggan computer with instructions. And then assert equals. That will be our expected result versus our computer.execute result. Okay, so that test passed. Now, ideally, we want to show that it fails as well. That's red, green, refactor. Make the test fail, then make it pass, then refactor so that you've got everything the way you want it. And we can see that if I strip out the Mull10.2 instruction, it gives the wrong result. It gives only 27, which is 3 times 9. So that's behaving exactly as we expect. So now the difficulty is to parse the instructions out of the input string, which is this from str function. Let's start working on that. This is the actual challenge of the puzzle today. Let's take some example text. I'm going to reinstate this. Our result will be a TobogganComputer dot from str dot unwrap, and the result dot execute, and the result should be 20. So this will check for the valid case where there's no weird instructions going on. Then we can introduce some crap. And then maybe an invalid Mull as well. Let's say it's a dot instead of a comma. Now this should still be 20. This tests just the valid case. This tests some rubbish as well. And then we can even write a test against our test.text. Text, which is a horrible name. Don't copy that, but it's fine for this Advent of Code challenge. So our instructions in this case will be include string // puzzle test.text. The result will be the same, and this time it's 161. Okay. Test valid, test invalid Mull instruction. Okay, now these should fail because we don't currently have any parsing logic. So that's one parse, 3 failed, exactly as expected. So now let's write from str. Okay, so the way that I initially thought of how to do this is to create a stack. I'm going to keep pushing values onto the stack as long as they meet my expectation of what a valid result is. However, I think it's probably much easier to parse this using a regular expression. So if you haven't used a regular expression before, it's essentially a string that you can use which identifies possible I'm explaining this poorly because I'm coding as I talk about it. It's a way that you can search for regular expressions within a test string. So in this case, I can define a regular expression that looks for valid Mull operations. So I can, for instance, match against integers. I can match any digit. So let's say \d, except I want as many Ds as are available. And then I want, so what I did there, if you look at the highlight, and that's the reason I'm using this Regex tester website, it's currently highlighting Mull 3, but I want it to highlight Mull 32. So I want to say not just one digit, but as many digits as you can find. And now it's highlighting the 2 digits, and that will work for as many digits as you can have. And now put a comma, I can put the \d start again, and then put the other bracket. And I'm doing \bracket because brackets are a regular expression token that you can make a group with. So I need to escape it to be able to use a round bracket. So this regular expression pulls out all of the valid Mulls within this string. Now the next thing that I want to do is I want to be able to group it. So I want to put brackets around the two values that I want to multiply. Okay, so this will be my regular expression string. I can quickly Google for regex, and I think it's a crate I have to install, so I'm going to add cargo add regex, and now I have that available in my code. And I can now let re equals. I just want to paste my regular expression so that I can paste other stuff. Okay. I'll change this to this. I don't want to unwrap it, so I'm going to match this. If it's some re, then give me the re back, and if it's none, then return an error. I am assuming that new gives me a result here. Yeah, new gives me a result. So I can do a regex error. Yes. And then, instead of using this match statement, I can just use a question mark. That's Rust syntactic sugar to basically say exit early if the error exists. So you see, if this is an error, return early with that error. If not, then take the value out and give it back. So now I have a valid regex, however you prefer to pronounce it. Now I want to use the regex. So I'm going to copy and paste that code and I guess format it. This is looking for haystack hey, but that's not what we're looking at. We're actually looking at S, or I'm going to rename it to puzzle. Puzzle. Okay, I don't think I need any of that information. Let's instead do for result in re.captures iter from puzzle and look at what that type is. Okay, so it is a capture. That groups is result dot. So I want to get the groups out of it. This is actually giving groups back. So that's why. So it's that's why it's path something something, which is great. So that means that I can actually use this as it is. I can do for comma, and then I can do the array, and I can do left and right. I can take that map and copy it there. And then my results can push an instruction Mull from left.parse, right.parse. But that's probably not going to be happy because parse needs to be unwrapped. So let's just do that and change this for instructions. Then I can remove this colon. Now, because we don't have I32 here, we're trying to give results, it's complaining. So let's start pulling those out properly. Left is left.parse dot. Now we could do an unwrap or 0, which will just give us a 0 whatever happens, and that will have no effect on the output, but that's not really what we're trying to do here. We're trying to give a result if something has gone wrong. So instead, I'm going to use another crate. This crate is called anyhow, and it goes really well with another crate called this error, but unfortunately I can't remember which one is which. So I just wanted to double check, and I think this is the right one. So what we can do here is I can define anyhow error, and then I can still use the question mark on the regex, but I can also use it directly on left.parse and right.parse, which is pretty tricky, but essentially what it's doing is the same question mark operator. If this is an error, return early from the function, and anyhow error will convert the parsing error into an anyhow error automatically, which means we can have multiple types of errors being returned. So by doing that, I can collapse this down to left.parse question mark, right.parse question mark. That makes our code a lot nicer. Now at this point, the regex is doing all the heavy lifting of skipping the invalid characters. We are parsing out the instructions, so we should be able to cargo test and get all passes. And that's it, 4 passed. So let's now try it on our full puzzle input. Okay, I just updated the main function to actually execute the program code. So let's now cargo run instead of cargo test. And that's our result. Plug it in. And that's the right answer. So now we can move on to part 2 of day 3. So now I'm going to read through this. Interesting. Okay, so we're now using do and don't to enable or disable doing multiplication operations. So this is going to throw a bit of a spanner in the works with my test function. This test text. Once this is finished, our result actually becomes 48. So we can cargo test this, and it fails. Okay, so we're going to change our execute code. Now we can't simply do a map to multiply the things together and then sum them together. Now we need to make it a bit more intelligent. So we're going to create an enabled flag. We're also going to create a new instruction, do and don't. And now we can do for instruction in self.instructions. And an accumulator. Accumulator is 0. Okay, so for each instruction, we'll match the instruction. If it's a do, then enabled is true. If it is a don't, then enabled is false. And if it is a mull, with X and Y. Then we will do, can't remember if the ternary operator is in Rust. I don't think it is. Y or 0. It is not in. Okay, so I'll just do if enabled X times Y. Yeah, you can one line this. X times Y else 0. And then this needs to be a comma. Then at the end, we just return the accumulator. Okay, why is that unhappy? Accumulator adds on X times Y, and then we don't need the else statement. Can't move out of self.instructions, so we just need to borrow self.instructions instead, and that seems to be working. Let's test it. We're going to rename this Mull only, and then we're going to create another version of this. With do, don't. This time we're going to have a Mull while it's enabled. A disable instruction. Another Mull followed by an enable, and then one last Mull. Let's change some numbers around here. Let's do 2 and 3 to make 6. Then 4 and 5 makes 20. And then 6 and 7 makes 42. So our correct result is 42 plus 6, which is 48. So at this point, without changing any parsing code, our computer should be able to handle those extra instructions. We just need to pull them out. Test text will fail because we haven't updated the parsing yet. So let's run this and they will pass. Yeah. So enabled, disabled logic is correct. There we go. It's also complaining at me for not using imports correctly. Okay, do and don't, that's done. So now we want to expand the regex string to also include do or don't. So let us do that. I think we need an or do or don't. But this test string doesn't include. Okay, so this is a different test string. I had assumed it was the same. All right, in that case, oops. That is a problem. Okay, so the problem is that do is contained within don't. Okay, so a don't in the answer string actually matches the do. So I'll come back to that in a moment. I want to fix the test first. So this is now actually, this is still correct, which is 161. We're going to create another test do don't.text, which will contain the new puzzle text, test text. Test do don't text do don't, which apparently has the correct result of 48. So this should pass and this should fail. And we have one fail, which is test do don't text, because it doesn't handle the do don't case. Okay, so now all we need to do is fix this. So I think one way that we can do it is to only match do if the next character is not an n. But that won't work if we get don dash. So if we get don dash, that should give us do, not don't. But if I say only match if the next character after do is not an n, then it won't match that. But I can demonstrate this. So this should give me do, which it currently does. But if I say not n, I've forgotten how to do the not here. Character not in the range, it's a little hat. So if I do dash n, you see it now doesn't match this, but it should give us at least do. I don't know if the order matters in the regex. Maybe we can get away with just doing that. That does match don't first and then do. So that might be okay. I'm not sure if that's truly valid, but I'm going to use it because it works in the tester. Okay, so now we need to change this to be I'm going to put a group around each instruction name, which will change our regex logic. So now we are going to and we're going to ignore the first argument, and then we're going to take the instruction name. Actually, what we can do is for capture in ri.captures iter from puzzle. We should be able to get the group from it. So can we get? We can, and the first one is the entire string. Group 0 is always the entire string. So we really want get 1. So we want match on that, and it will either be Mull, it will be don't, or it will be do. At this point, I can directly return a don't. I can directly return a do, and I just need to do slightly more parsing, slightly more processing to get the values out for the Mull function. So this should now be I should be able to get a left is capture.get2.parse. So you can use 2 question marks in the same line. And I'll do the same with the right, capture.get3.parse. Then I can return an instruction Mull with left and rights. I think that should work. Let's run the tests. And it didn't, because it returns an option, not a result. So can I do is sum? Convert option to result is what I would like to do. Yes, so I can, instead of this, do OK or, and then I can give it some error. Mull left operand not found, question mark. The question mark should go here. That okay? Let expressions are not supported here. Clearly done something wrong. Okay. I'm expecting... So get returns me an option of a match. And apparently I need to do this to convert it to a string. Is that it? Some mull. Oh, and then I need to get rid of this. Okay, so I convert it to an empty string if it actually doesn't have anything there, which means I should handle the default case where I return any anyhow error. Unrecognized instruction. I need to format a string, which would be capture.get1, I guess. Okay, so that should be happy, but we need to do the same thing here. Okay, so let get int. I'll just use a closure because there's too much gunk on the screen. So I'm going to take index, and I'm going to return index. I'm going to map or dot parse. I don't know what happens. I'm going to give it a bad default that can't be parsed as an integer. I'm pretty sure that wouldn't work. Let left is get int 2. Let right is get int 3. I think I just deleted my new get int. Yes, did. Okay, that should be happy. Except that needs to return result or option. Fair enough. I don't know why that's not happy with it, actually. Okay, so I guess if I return the parse directly, then it'll be a result. And at that point, I can use question marks on these. There we go. So that's happy. This is unhappy because I suppose I can't construct it directly. What's its message? Anyhow message, anyhow error message. Creates it from a printable error message. That's probably what we want. But it's still unhappy. and it wants an error. Error. Capture.get. I can make this debug. Okay. That should now be working. And run cargo test. And it's failed. And I think it's failed on multiple of them. Okay, it's failed on valid Mull. So let's focus on that test. I'm going to copy, I'm going to comment all of them out and then focus on valid Mull. Here we go. Failed. It's got a match on the string of 5. Don't know why it's using a string of 5. So the unrecognized instruction is here. Oh, it's because I need to check whether it contains it. Okay, so let's, instead of using this match, we're going to use if-else statements and use a contains. So let instruction raw will be capture.get1.map or if instruction raw, come on, dot contains Mull, then we can actually move this up so that we can use it in other parsing if we want. Okay. And we can push this onto instructions. Else if inst raw.contains do, then it contains do, else if instruction raw contains don't, instructions push don't, and then we can even have an else statement with this text, because that was quite useful to have that full instruction there telling us what was wrong. Okay, at this point, it should be happier. Failed. Okay, and it's the same error. So I'm just going to print line here to say okay, check what this is now. Raw instruction is 5. I don't know why that is, so I'm going to print out the whole capture. And the whole capture is 1 is 5. So we've captured Mull, 5, and 4. I see. Okay. So the regex crate is working differently than I thought, and I can test my theory, which is that the groups stay the number that you put in the string. So if I put a do, then I should be able to check dot instructions should be a vector containing instruction do. That's it. Can I do a vec equals? This thinks I can do a vec equals. Partial equality needs to be written on instruction. Partial equality. Okay, now if I do this, this test should also fail. It does, and it fails because there was no instruction there. Right. Okay, so how the regex parsing code works, it's not the first group that it sees, it's the first group in the regex. So this is group 1, group 2, group 3, always group 4, always group 5. So I should be able to say let instruction raw or mull left, mull right. Do instruction, don't instruction equals capture dot extract. Okay, I'm just seeing at what point it fails here. Number of capture groups can vary in a match. Okay, that shorthand didn't work, unfortunately. So let's instead do if capture.get1.isSum. Then we're going to do the mull logic. Else if capture.get234 is sum. Then we're going to do the do logic. Else if capture.get5.isSum. Then we're going to do the don't logic. Finally, we don't know what it is. Then we'll capture.get0. Okay. We still need get int. We still need do. We still need don't. Okay, 2 failed still because unrecognized instruction string do. Okay, I think maybe I was right the first time. I'm going to copy it just so I've got it if I want it later. I think maybe when I said group 0 is always the whole string, that may have been wrong. So let's okay, we're going to print the raw instruction for both of these. Okay, the raw instruction. Did I just print out the whole capture? I did, yeah. let's print out the raw instruction. Raw instruction mull54. Okay. And on the do, because we didn't parse it right. Okay, so I just need to get 0 to begin with, and then that logic would have worked. So we still got get int here, so I actually just need to restore instructions.push instruction do, and instruction don't. Test failed. The mull instruction still failed because invalid digit was found in string. Because we need to update this index. So this index should now be 1 and 2. Okay. We'll uncomment those and run all the tests. 6 passed, 1 failed. Do don't text is failing. Why is do don't text failing? So we know that don't will correctly disable the computer. What we can do here actually is to print line the instructions in the computer. Result dot instructions and result dot execute. Okay. If I do that, then we can see what the computer thinks it's meant to be doing. Okay, so it currently has mull, don't, mull, do, mull. Mull 2.4, do, mull 5.5, 11.8, do. Okay, it's failing again. And that's because we've just repeated the mistake of having do inside don't. I think if we just swap those over, results are now okay. That's because it consumes don't first, and if it can't find a full don't, then it checks for do. Okay, so now with the test done, cargo run will give us the new result. Actually, we can get rid of all the print lines now. We can keep the one in the test because it's useful. It doesn't run in our normal code. Now I almost want a toggle so that I can print part A and part B at the same time, but I think I will keep it simple and just print part B. What? This is now giving me different results. This is the same result as before, I'm pretty sure. Okay, so I did something there that made it do cargo run. Yeah. And then I removed a print line. Okay. I don't know what I did there. It gave me the old result, and I'm not sure why. I guess I broke the parsing. But we are 1 gold star, close to finding the chief historian. That is day 3 solved. And what gave me the most trouble there was figuring out how the regex crate worked. Let that be a lesson. Read through the docs. That's something that I would have done if I was just coding for fun. But to try and keep it interesting on camera, I didn't want to sit there reading a page. So that ended up taking longer than it needed to. But we still got there in the end. And we have a solution that we can copy and paste into its own crate later if we do end up continuing this computer instruction parsing system that they've introduced. It may or may not happen. In previous years, there was an int code computer, which was a lot of fun. That was multiple days. Every other day would be spent making this int code computer more powerful. I really enjoyed that. Although some people didn't like it as much, I was a fan. And with that, I'll leave it there and see you tomorrow for day 4.